understand what hypothermia actually is, why it's so dangerous, how the body reacts and what we can do.
Basically pull out the most important stuff, the key takeaways.
Exactly. Okay, let's unpack this. So hypothermia, it's when the core body temp drops below, what, 35 C?
35 Celsius, yeah, or 95 Fahrenheit.
Mm-hmm.
And the sources make it clear it's a spectrum, starts mild, but can get very serious very fast.
Okay, so what are those first signals? What does the body do initially based on this material?
Well, the first big physiological responses are peripheral vasoconstriction. So blood vessels near the skin tighten up.
Especially hands and feet.
Exactly, hands and feet. It's not just about shunting blood away. It's really about cutting down heat loss to the cold environment from those areas.
Makes sense.
And then, of course, shivering. The muscles contracting rapidly to generate heat.
Right, like an internal furnace sort of kicking in. But interestingly, the sources also highlight that our main defense isn't internal at all, it's behavioral.
Oh, absolutely. Putting on a jacket, getting out of the wind, seeking shelter. That's usually step one.
Which makes total sense. So how do people actually get hypothermic then? It seems obvious, but...
Well, yeah, cold air exposure is the main one. But water immersion is particularly dangerous. The material really stresses how much quicker heat loss is in water.
How much quicker?
Significantly. Water at 10 degrees C, so about 50 degrees Fahrenheit, could be fatal in like an hour. Near freezing water, maybe 15, 30 minutes.
Wow.
And often the initial danger in cold water isn't even core hypothermia setting at first. It's things like cold shock, that gasp reflex, heart rate spikes, or cold incapacitation, just losing muscle function.
Okay, so that's a really crucial distinction from the sources. It's not just a slow cooling. What else bumps up the risk?
A huge one mentioned again and again is alcohol.
Right, the old winter warmer myth.
Exactly. It feels warm because it causes vasodilation near the skin, but that actually increases heat loss. Plus, it dampens shivering and just generally messes with the brain's ability to regulate temperature and, frankly, to recognize you're in danger.
There was a statistic in one of the papers, wasn't there? Pretty shocking.
Yeah, one study mentioned alcohol being involved in somewhere between like 33% and 73% of cases. That's a massive factor.
That really drives home the behavioral trap alcohol creates in the cold.
Absolutely. And then you have other factors being very young or very old, homelessness, obviously, low blood sugar, trauma, certain medical conditions.
The material even gave historical context, like Napoleon's retreat, shows this isn't a new issue.
Not at all.
Okay, so risks, initial defenses. What happens as it gets worse? What are the more severe signs the material talks about?
Well, as those initial defenses like shivering start to fail, things get more serious. Shivering might actually stop. You see decreased reflexes, slurred speech, drowsiness, really poor judgment.
And this is where some of the stranger symptoms can crop up, right?
Yep. Exactly. Things like paradoxical undressing.
Where people start taking clothes off?
Yeah, they're confused, maybe feel paradoxically warm as blood flow regulation completely fails, and they remove clothing, which just makes things catastrophically worse.
That's you.
And then there's terminal burrowing, this really strange, almost instinctive urge to crawl into small, confined spaces.
Like an animal seeking shelter.
Kind of, yeah. It's described as this primitive, last-ditch attempt, but totally ineffective by that stage as the brain is shutting down.
That burrowing thing is just incredibly grim, but also fascinating, biologically speaking, a breakdown of survival instincts. So how do you even diagnose this properly when someone's that cold?
Good question. For moderate to severe cases, you need special low-reading thermometers. Standard ones just don't go low enough. Often rectal or esophageal probes are needed for an accurate core temp.
Right.
And the source is stress checking for a pulse for a long time, like 30 to 60 seconds, because the heart rate can be incredibly slow, almost undetectable.
And there was something about an ECG pattern.
Yes, the Osborne J wave. It's a specific blip on the ECG that can show up. Sometimes mistaken for a heart attack sign, but it's a classic indicator of hypothermia.
Huh, interesting. Okay, before treatment prevention, basic tips the sources cover.
Crucial stuff. Layers, obviously. Woolen synthetics are way better than cotton if there's any chance of getting wet. Staying dry is huge.
Makes sense.
Staying hydrated, keeping energy levels up with food. Covering the head is good, but that old idea you lose most heat through your head. Maybe not quite accurate for adults, unless it's the only exposed part. Still important to cover it, though.
Okay, so someone is hypothermic. What do the sources say about bringing them back?
It really depends on how severe it is. Mild cases, passive rewarming, dry clothes, warm environment, maybe warm drinks if they're conscious.
Simple enough.
Moderate cases need active external warming heating blankets, forced air warmers, things like that. Severe cases, though, that often requires active internal rewarming.
Like warmed 5e fluids.
Warm 4 fluids, sometimes warm humidified oxygen, or even more invasive stuff for the really critical patients, like ECMO, essentially warming the blood outside the body.
Wow, that's intensive.
It is. And a key warning across the sources is gentle handling. Rough movement can trigger cardiac arrest in a severely cold heart.
And definitely no hot baths or rubbing them down vigorously at first, right?
Absolutely not. That can cause rewarming shock. Blood vessels in the cold limbs suddenly dilate, blood pressure plummets. Very dangerous.
That hot bath warning is so counterintuitive. It feels like the first thing you'd want to do. And the Mountain Rescue Survey kind of brings all this ideal treatment back to Earth, doesn't it?
It really does. It highlights the huge gap between knowing the guidelines and being able to apply them in the field, on the side of a mountain.
What kind of gaps?
Well, the survey found that many trained rescue teams often lack kit recommended for severe cases, those special low-reading thermometers, for instance, or portable devices to check blood potassium, really important because cold plus potential crush injury can mess with heart rhythms during rescue. Even things like mechanical CPR devices for prolonged resuscitation.
So it's not just about knowing the science, it's the practical challenge of actually having the gear and being able to use it effectively out there.
Exactly that. Looking across all this material, what's really striking is this story of the body's, quite elegant initial fight against the cold, the vasoconstriction, the shivering, but then how quickly those defenses can just be overwhelmed.
Leading to this cascade failure.
Right, and the need for really complex, specialized care. And that Mountain Rescue Survey just puts a sharp focus on the real-world difficulties of delivering that care where it's often most needed.
Brings the lab science right down to the cold, hard ground. So thinking about those extreme behaviors, considering how hard our biology tries to keep us alive, what does that tunnel burrowing information, that bizarre, seemingly self-defeating urge to hide at the very end, what does that really tell us about the absolute limits of our innate survival instincts when things get truly overwhelming? Something to ponder.
It really is.
Thanks for joining us for this deep dive. Keep exploring.